Hello, awesome CC3 students, and welcome back. In this review video, we're going to be going over evaluating expressions in function notation. So evaluate pretty much means simplify the expression for a specific value of X or whatever the variable is. And function notation is just a way of showing us a specific function for a specific variable. So we would read this equation as f of X equals 3X plus 4. F is the name of the function. This is function f. It's very specific because in function f, x is being multiplied by 3 and then we're adding 4 to it. So that's a very specific relationship that's happening here. And then x just represents the variable in the expression. So if this was instead an m or an o, you would see an m or an o here. But in this case, we're looking at function f in terms of x. So when we're actually evaluating, what will happen is that you'll be given a value to substitute in for x. So I might like to say, okay, what's f of 6? F of 6 means, tell me what the value of function f is when x is 6. So to do that, all we do is we substitute 6 for x. So now instead of x multiplied by 3 plus 4, it's 6 multiplied by 3 plus 4. And then we simplify. So f of 6 is 18 plus 4, and f of 6 is 22. What's really cool about function notation is that you can keep organized throughout. So the entire time you see what function you're using and the specific input that you use. So at the end, it shows me I inputted 6 and I outputted 22. So if I needed to graph that, I could graph that as an ordered pair of 6, 22. Here's my input, which is my x, and here's my output, which is my f of x, or on a graph, you would call that your y. So now we're going to look at evaluating in function notation. This time, we're going to be given a function. We're going to be given specific values to substitute in. We're going to fill in those values into a table, and then we're going to actually graph those ordered pairs to take a look at what they look like. So here's our first example. We're doing a worksheet practice, function tables and graphs. The directions tell us to evaluate the function for the given values of x to graph a set of solutions. So here we go. We have our function. In this case, we're also looking at function f of x, and it's equal to 2x minus 4, and these are the 4 values that we're inputting. So I'm just going to think of this as, okay, I want to evaluate function f when x is -1. So that would mean f of -1 is 2 times -1 minus 4. In other words, I'm just substituting in. So that means f of -1 is -2 minus 4, and -2 minus 4 is -6. So when I inputted -1, my output was -6. So what is that as an ordered pair? As an ordered pair, that would be the ordered pair -1, -6. And that's a very specific input-output pair that happens for this function. So over here, if I wanted to graph it, I would go to -1, -6, and that's called a solution point. The key word there is solution, because solution means the value of the variables that make the function true. When I put -1 for x, I get -6 for my output. Now notice here, we call this the y-axis. The y-axis is essentially your output, which is, in this case, f of x. So when you're plotting your points, remember f of x on an axis is basically just y. Okay, now we're going to do the same thing for an input of 0. So let me grab a different color here. So here we go. Now we're finding f of 0. So we're plugging in 2 times 0 minus 4. So f of 0 would be 2 times 0 is 0 minus 4, and 0 minus 4 is -4. So when we inputted 0, our output was -4. So coming over here, our output 0, y is 0, input -4. 2 more points to go. Over here, f of 1 is 2 times 1 minus 4. F of 1 is 2 minus 4, and 2 minus 4 is -2. So our input was 1, our output's -2, 1, -2. And our last point, input 2, 2 times 2 minus 4, So f of 2 is 2 times 2 is 4 minus 4, and 4 minus 4 is 0. So our input was 2 and our output was 0. Now, what do you notice about these points? Are they just kind of all over the place in the graph, or is there something that you see here? I notice that if I were to grab a line, I would be able to draw it through all 4 points, and it would hit all 4 points exactly. That's because this is something called a linear function, that the solutions of this function happen to form a line each time. And even more, this line has a very specific change or a very specific way to get from each point to the next point. You'll notice to get from blue to green, I go up 2 and right 1, and from green to red, up 2 and right 1, and from red to purple, up 2 and right 1. And that continues because that's actually something called the slope of the line, and that happens to be the number right there. That's a discussion for another time, but this is the basic premise of this is that we are evaluating this function for different values of x and ending up with different outputs. Notice that in my work, I maintain the structure of function notation throughout. So through the entire thing, you can see that I'm using function f and I'm plugging in very specifically -1. Here I'm using function f and I'm plugging in 0. Here I'm using function f and plugging in 1, and so on and so forth. So it is important while you're working to maintain your structure and to keep your work organized. Moving on, if we do the second example here, we'll just do 2 from here, and then I'll let you kind of finish this. So now we have function g. Notice how function g is different from function f, because that was unique to function f. We're dealing with a new function now, which is why we have g of x. G of x equals -x plus 3. So we're going to start by substituting in -4. So g of -4 equals. Now, -x, that's a little bit tough. -x really means -1x. There is a hidden -1 there. So when you substitute in, you're really taking your input and you're multiplying it by -1. So this is -1 times -4 plus 3. So g of -4, -1 times -4 is 4, plus 3 is 7. So my input was -4, my output was, 7, okay? So -4, and my graph stops at 6, so I'm just gonna kind of eyeball it. There's -4, 7. Okay, moving on, let's go ahead and do g of -2. Which is -1 times -2 plus 3. G of -2, -1 times -2 is 2, plus 3 is 5. So -2 gave me an output of 5. And there we go. Now, you can start to imagine, because this is a linear function again, your solution should end up on a straight line. So let's say, for example, I make a mistake. You're going to be able to tell pretty quickly that you made a mistake. So let's say I go to plug in g of 0. And I make one of the most common mistakes that students make, where I say, oh, -1 times 0, that's just -1, and -1 plus 3 is 2. So I plugged in 0 and I got 2. I know that's wrong, but I'm just pointing it out to you. If I plug 0, 2, what happens here is that if I go to draw a line, what do you notice about my red point? It doesn't fall on that same line, which means that I actually did my math incorrectly, and that's how you can tell. So if you end up with a bunch of points all over the place, like a point over here and a point over there and a point over there, you probably need to go back and check your work, because chances are you made a mistake. So I'm going to get rid of all of that, because I know that I made a mistake here. And my mistake was that -1 times 0 is not -1. -1 times 0 is 0. So that's how you can tell. Oops, this is 0. That's how you can tell if you made a mistake. If those points, in this case, because it's a linear function, don't line up. So now I did it again and I got 0, 3. Let's see here. If I were to draw a line, Would they all fall on the same line? Yes, they do. So that's how you can tell that you did that one right. So I'll leave the last one 3 for you to try, and then you can see, you can almost kind of see where it's heading, right? Like, what is going to be my output of 3? I don't really know. But I'll leave that one for you to try while we move on to looking at some examples from IXL. Okay, for these examples from IXL, we're looking at code, what is the code here? It's JFG, JFG. Okay, so let's get right down to it. So complete the table and then graph the function. So we have a table, it's very similar to what we were doing. We have a function, and then we're going to graph those solutions to the function. So here we go. If I'm doing work on a separate sheet of paper, I'm thinking to myself, I'm going to evaluate function f for these values 2, 3, 4, and 6. So my first step would be, okay, f of 2 is, and then I'm plugging in 2 for x, 2 plus 4. So f of 2 is 6. So I know over here, my first value is going to be 6. Now, second value is 3. So f of 3 is 3 plus 4. 3 plus 4 is 7. So f of 3 is 7. Again, come over here, type in 7. 2 more. F of 4, oops. F of 4 is 4 plus 4. And 4 plus 4 is 8. I'm coming over here and I'm putting in 8. And then finally, f of 6 is 6 plus 4. And 6 plus 4 is 10. So I'm going to come over here and input 10. Now notice that there's a pattern that happens here. If you take the x value and you add 4, you end up with the f of x value. 2 plus 4 is 6, 3 plus 4 is 7, 4 plus 4 is 8, 6 plus 4 is 10. That's because the relation here, the function here, is that you're adding 4 each time. So I'm going to get rid of all my drawings and come down here. Now I need to graph these points. So the first one is 2, 6. So I go to 2, oops, and then up to 6, and that's the first solution point. Then we have 3, 7, and look, a line started forming already. But just to make sure that my other 2 points are correct, I'm going to go ahead and check them. 4, 8 is right there, which is on the line, yay, and 6, 10, right there, also on the line, yay. Now, if these other 2 points weren't on the line, then I would be a little bit worried because that means that I probably made a mistake. But in this case, they are on the line, so I feel pretty good about that. All right, so that's the basic premise of evaluating in function notation. Again, if you want to keep your work organized, always suggest showing what function you're using and the input in all of your work. At the end, you'll be shown what you inputted and what you outputted, and then it's really easy just to write it as an ordered pair. That's it for today's video. Have fun evaluating in function notation, and see you next time.